Hello and welcome class. So we was doing chapter number 7 motion, and in last class we studied about graphical representation of motion, and we have learned about distance time graph and velocity time graph. In today's class we will solve few questions and then we will learn about equations of motion. So let's begin. These questions are from the topic graphical representation of motion. And question number one is, what is the nature of distance time plot for uniform and non-uniform motion of an object? You have to tell about nature of distance time graph. Nature means it's a straight line or not. Okay. For uniform and non-uniform motion. And what is the answer of this question? The answer of this question is, for the uniform motion, if the motion is uniform, the distance time curve is a straight line. Straight line. Okay. When the motion is uniform, the distance time curve is a straight line. And if the motion is not uniform, it means velocity is continuously changing or body is accelerating, then we will get any curve. So, what is the nature for uniform motion? We get a straight line. For non uniform motion, we get any curve. Clear class? This is the solution of question number first. Now let's move on to next question. Next question is, what can you say about the motion of any object whose distance time graph is a straight line parallel to time axis? So we have a distance time graph. Time is always in x axis. On y axis we have distance. Okay. So distance time graph, a graph which is straight line parallel to time axis, which type of motion or what can you say about the motion of this type of graph? So according to this graph, time is increasing, but distance is not changing. Distance is not changing. If distance does not change, but time is continuously moving, what does it means? I am sitting here, okay? So my distance is not changing, but we know that the time is continuously changing because you can see your watch, you can see the time. Huh? So time is continuously increasing, but distance is not changing. So which position I am? Motion or rest? So I am at rest position. So this graph told us about rest. Distance does not change, but time change, so object is at rest position. So there is no motion associated to it. If the distance time graph of a straight line parallel to time axis, then the body is at rest and the curve is like this, not this. The curve is like that. Let's move on to next question. Next question is, what can you say about the motion of an object if its speed time graph is a straight line parallel to time axis? So this is time and this is speed, and the speed time curve is parallel to time axis. What does it means? So speed is not changing, but time is continuously increasing. So area is increasing. It means it's an uniform motion where speed does not change. Uniform motion. Clear, class? So object is moving uniformly. It's an uniform motion. Time increases, but speed does not change. Speed is not changing. It means the object is doing uniform motion. Next question, question number 4 is what is the quantity which is measured by area occupied by the velocity time graph? This is our time axis. This is velocity, and the velocity time curve is something like this. No, it's always a straight line. Velocity time curve is always a straight line. Remember that. And you have to calculate the area between these two time intervals. So what does this area give? In a velocity time curve, what will this area will give you? And this area is displacement. So the area between velocity time curve give distance or displacement. Dear class. So area between velocity time curve give distance or displacement, depends according to question. Okay. Displacement is also a correct answer. Very good. So we have completed our topic graphical representation of motion. Now we will use that graphical representation of velocity time curve and we will find out three equation of motion. Those three equation help us to describe all information about the motion. So let's understand the topic equations of motion. Clear, class? When an object moves along a straight line with uniform acceleration, remember for equation of motion, acceleration should be uniform. It is possible to relate velocity, acceleration during motion, and distance covered by it in a certain time interval by set of equation known as equation of motion. Means we have three equation which help us to relate uh, distance, time, initial velocity, final velocity, and acceleration. We have three set of equation which help us to relate these topic by each other. Okay, and which three equations are there? These are the three equation. First equation number first, equation number second, and this is third equation of motion. First equation relate initial velocity, final velocity, acceleration, and time. V equals to U plus AT. Second equation is S equals to UT plus half. S equals to UT plus half A T square. Okay. This is second equation of motion, and third equation is V square equals to U square plus 2AS. Now what are the use of three equations? Suppose you have velocity. You have initial velocity, you have final velocity. You want to calculate acceleration and you have time period. So you will use this equation number 1 to calculate acceleration. Let's suppose you do not have time period, but you have displacement. Then what will you do? You will use third equation to calculate acceleration. Similarly, if you have initial velocity, time period, and distance, you can calculate acceleration using equation number 2. If you has u, you have t, s, t and u, you can calculate acceleration using second equation of motion. So these three are three equation of motion where v is final velocity, u is initial velocity, a is acceleration, t is time period, and s is distance traveled by the object. Clear, class? So you have to remember all these three equations because in future other chapter, motion, work, energy, in every chapter you are going to use these three equations to calculate certain things. So these three equations are the most important equation in whole physics book in class 9. Very, very important. Okay, class? So these three are very important for us. Now let's move further. We will try to drive it. Equation number first, which is v equals to u plus at. Take the use of velocity time curve to calculate acceleration. Equation number 2, which is s equals to ut plus half at square, came out from the position time relation st graph. And third equation is the mixture of both the equation where we eliminate t variable. Okay, v square equal to u square plus 2a s. No time period here. These three equations can be derived by graphical method. Now what we are going to do, we are going to derive these three equations using graphical method. Okay. So we will first calculate. Let's suppose this is a velocity time curve. This is initial velocity u and this is final velocity v, and you want to this is 0 and this is time t. Okay, and you want to calculate these three equations. So first equation is direct. From the formula of acceleration, which is v minus u divided by t give acceleration, multiply t here, which implies v minus u equals to at or v equals to u plus at. This is equation number first. How you're going to calculate equation number second? You have to calculate distance, and the area of velocity time curve give you distance. So we will calculate this area. And how you are going to calculate? This denominator, this length is t. What will be this length? This length is v minus u. Okay. So what is distance? Distance is area of triangle multiplied by area of rectangle. Area of rectangle is u times t, ut, plus what is the area of triangle? Half. Base, what is base? Ut is base. And what is height? Height is v minus u. And from here we know that v minus u is at. So we will replace v minus u by at. We will get s equals to ut plus half a t square. And after simplifying these two equation, we will get third equation, which is v square equal to u square plus 2as. So taking the help of velocity time curve, we can calculate these three equation of motion. But most important thing is to remember all these three equation and how to use it. So we are going to solve some examples to learn how to use this equation. Let's solve some example. So example 7.5 is a train starting from rest. Starting from rest means initial velocity u is 0. Okay, and attain a velocity of 72 kilometer per hour in 5 minutes. Time is 5 minutes. Convert 5 minutes into second, 5 into 60 seconds, which is 300 seconds. Assuming that the acceleration is uniform, we have to assume acceleration is uniform first. In first part, you have to calculate acceleration. In second part, you have to calculate distance. How you're going to calculate these two terms? We are going to take help of three equation of motion. Which are the three equation of motion? Equation number first is V equals to U plus AT. Equation number 2 is S equals to UT plus half AT square. Third equation is V square equal to U square plus 2AS. So we have to first calculate acceleration. Let's check equation number 1. We have V, exactly. We have U and we have time. So we will use first equation to calculate acceleration. Can we use second equation to calculate S? We have U, we have T, we will find out A. So we can use second equation to calculate distance traveled by the object. So for finding the first part, we will use first equation of motion, and to calculate the second part, we will first use the value of acceleration, which we have already find out from the equation number 1, and put that value in equation number 2 to find out the second part. Is this question clear to all of you? So let's see its detailed solution. So the train begin from rest. So initial velocity is 0, final velocity is 72 kilometer per hour. We will change kilometer per hour in meter per second by multiplying by 5 by 18. So in meter per second, the answer is 20 meter per second. Time given is 5 minutes, which is 300 seconds. We will use first equation of motion, which is V equals to U plus AT to calculate acceleration. V is 20, U is 0, and T is 300. We will put all the values and we will get acceleration as 1 by 15. And here I am showing you how to calculate displacement using third equation of motion, which is V square equal to U square plus 2AS. U is 0, V is 20, S is 1 by 15, V is 20, we have to calculate S, and A is 1 by 15. So distance we find out is 3 kilometer per hour, and acceleration is 1 by 15 meter per second square. Is this question clear to you, class? I hope so. So let's move on to next question. Question number 7.6. A car accelerated uniformly from 18 kilometer per hour to 36 kilometer per hour. Okay, so car initial velocity is 18 kilometer per hour. We have to convert it in meter per second, and final velocity is 36 kilometer per hour, and time period is 5 seconds. We have to calculate acceleration and distance similarly like previous question. So we can, for acceleration we will use V equals to U plus AT, and for S we are going to use V square equal to U square plus 2AS, or S equals to UT plus half AT square. Both answer will be correct. Same answer. So the answer will be, first we are going to convert initial velocity into meter per second, which is 5 meter per second. Final velocity is 10 meter per second. time period is 5 seconds. So from first equation of motion, acceleration is 1 meter per second square. So we have find out acceleration. Now we have to calculate distance. Okay. This one question we are solving using second equation. You can again solve it by using third equation. Second equation is convenient as acceleration is 1 and time is 5 seconds. So these are simple value to solve. So we will use second equation of motion. U is 5, T is 5, half, acceleration is 1 and this is 5. 25 plus 12.5, distance is 37.5 meter. So the acceleration of car is 1 meter per second square and distance covered by it is 37.5 meter. Clear? Next question. Example 7.7. The brakes applied to a car produce an acceleration of 6 meter per second square. Opposite direction to the motion. The car takes time period of 2 seconds to stop. Okay. 2 seconds to stop. So car was moving with a speed with an acceleration of 6 meter per second and you applied a brake and car took 2 seconds to stop. It means final velocity is 0. We have to calculate the distance. Calculate the distance of it traveled during this same. You have to calculate distance. How you're going to calculate it? To calculate distance, we first need one more thing, which is initial velocity u. So first, we have to calculate initial velocity, then we are going to calculate distance. Okay, because in 3 equation of motion, okay, we know v, we know acceleration, we know time period. We can easily calculate initial velocity using this, and then we can put the value of initial velocity in this equation or this equation to calculate distance. Clear, class? Because we cannot calculate distance using any equation because we do not have initial velocity and both equations needs initial velocity. So our step 1 will be to calculate initial velocity, then we are going to calculate the distance. So as we are applying brake, so acceleration will be a negative acceleration. So v equals to u plus at. Final velocity is 0. We have to calculate u. Acceleration is 6 and time is 2. So initial velocity is 12 meter per second. This is our initial velocity and we will use our second equation of motion, which is s equals to ut plus half at square. U is 12, t is 2 plus half minus 6 into 2 square. The distance is 12 meters. This is the distance which we want to calculate. Thus, the car will move 12 meters before it stops after application of brake. Can you now appreciate why drivers are cautious to maintain some distance between vehicle while traveling on the road? So now it is clear that why two cars are driven. There is difference. There is a distance between two cars when you drive, because whenever you apply brakes, like we applied brake when car was accelerating with 6 meter per second square, we applied brake and the car move 12 meter. You pressed brake here and the car moved 12 meter. Then the car stops. So that's why you have to maintain distance between two vehicles so that if the behind one vehicle applies brake, it does not hit the front one vehicle. Is it clear, class? So in today's class, we have completed our motion in a straight line part in which we first studied what is distance, then displacement, speed, velocity, acceleration, and there are two types of acceleration: uniform acceleration and non-uniform acceleration. Then we learned about the graphical representation of the motion, and in the end we studied the three equation of motion, which were the three equation: v equals to u plus at, s equals to ut plus half at square, and v square equals to u square plus 2as. These are the three equation of motion. And from here, our motion in a straight line part is completed. In next class, we will study the uh, motion in circular path or uniform circular motion. I hope today's class is clear to you. Now we will meet in next class. Thank you.